Hey everyone, and welcome back. I've got some responsibilities to tend to, so instead of doing those, I'm just going to have some fun with this cheap CPU cooler. Now, there'll be a link for this in the description below. This is pretty much the cheapest CPU cooler you can buy. It's maybe a little bit more expensive now since COVID, but pre-COVID, it was extremely cheap. I would not recommend to buy this at all because, well, first of all, it is made out of nearly nothing. And I mean, there's like nothing to this thing. Only thing missing is two tiny screws from this. And it weighs 156 grams, maybe a little bit more if I put the plug on top. Can I support it like that? 158 grams. That includes the copper inside these wires. That is terrible. It is held in just by two screws. You just work it back in. One in here and one in here. And I remove those. And the reason why this thing is going to the slaughter, it's because I broke it. I literally grabbed it, my finger slipped, and this came around while it was running. It came around and hit my thumb, and it just snapped, the blade went flying. It snapped it right off. But I figured it is a little bit interesting, so I would show you what it's all about. Here's the metal bit of it, and that's only 81 grams. That's it. There is like nothing to this. But it is made really interestingly. So I don't know if you can quite see this, but it looks like there's these 5 pieces of metal here, 5 pieces of metal here. They're like a U shape, right? With the screw holes here and here. Same thing on the other side, here and here. And they're actually dual screw holes, so you can use some version of this fan on top. But then the rest of this, these are all these pieces of metal here that were all squeezed together and then riveted with these look like aluminum rivets. So these pieces here, like for example this one here on the inside, actually comes around like this, across like this, and up like this. So this is kind of made by sandwiching these metal plates with these two and then fanning them out to make a semicircle like this. That's pretty impressive. I would say if you're going to buy this from the link in the description, I wouldn't bother. I would look on your local Craigslist or Kijiji or Gumtree, whatever you have, and I would get a used Intel or AMD cooler. Way better value than this thing, and you can usually pick them up for free or next to free. But I'm going to drill these two things out. Maybe I'll try just hammering the rivet ends out, and we're going to take this apart, see if I can get all the leaves out. See if I can nibble these. Looks like these rivets are just aluminum, so I might get lucky and be able to break them off. Getting some progress here. Looks like one of the fins is loose. So that one didn't go all the way around. Sure looks like the rest did though. I might regret this. Whoa, I went flying. Got to be close to cracking it now. Oh, I got it. Yes. So that's out. Should be able to pull this one out now. Either way, I can slide these off. So these are now crimped around the edge here. Oh yeah, they're interlocked. Interesting. Let's see if I can get a couple of them out. So again, some of the edge ones here are just crimped together. Oh, you know, I think I was wrong. Oh no, that's it. They do go all the way across. I just don't know how to uncrimp these. There we go, give them a little bend. Oh, even the ones I took off. Even the ones from before. They actually did continue into here. You need to bend these. There we go. Just gotta bend this like this. And there we go. These are the individual pieces. Wow, these weigh nothing. Look at that. So interesting. They have pressed indentations in them to give them a bit more strength. See that? So interesting. Then yeah, you can probably yank these all out. There we go. So these are the individual blades here. And they're all crimped together. Look at that. Very neat. They have these channels that the guide pins that guide themselves on these pins. And there we go. That's the crux of the problem. Look at that. So even though you have a nice flat surface here, it's hollow. So really only you're getting like the thickness of this here. This is completely hollow. They could have improved this greatly. Still not obviously ideal, but they could have improved it greatly by leaving these filled in. This, and this. But the reason why they stamp those out is because they melt that metal, the waste. They melt it down and make more of these. This is ridiculous. So that is interesting mechanical engineering and, you know, cost savings, but at the cost of a useful product. Like, this would have been way more useful if it had more thermal mass. You know, it could absorb more energy and then attempt to dissipate that energy. This one's still jammed in there. I'm not sure why. But yeah, that's it. It's just these fins that were compressed together with a strong, probably a hydraulic press, and then the two ends were peened over to make these little rivets. Really neat stuff. Alright, let's take a look at this motor now. Okay, this might be frivolous to keep in, or this might be impossible, I should say, to keep in focus, but we're going to try anyways. By the way, even these little end pieces, only the outermost aluminum is full. The other ones, they save that just couple grams of aluminum. But anyways, here we're looking at the backside of the fan. And you first of all, you'll see there are 4 solder points. Most fans, PC fans, they are CPU cooler fans, I should say. They have 4 wires on them. So it would be ground, 5 volts, I believe it's 5 volts, no, 12 volts. So ground, 12 volts, a tachometer signal that tells the motherboard or whatever how fast it's going, and then a 4th, which is a PWM signal to control the speed of this. It seems as though they used a motor that has that implemented, that PWM control, because there is the 4th solder pad down there. But to save a couple of pennies, maybe a single penny, they didn't route that last wire out and they didn't put a 4-pin plug. So yeah. Here's an interesting thing though. If you get one of these coolers yourself, typically there is no good way to get it apart. So there's no screws or anything visible. You just kind of have to hope it doesn't break. So I'm going to be pushing on this, and this might break. Oh, something gave. I'm not sure what. Oh, I think the plastic, oh yeah, the plastic is breaking here. See that? Right there. So we might not get this apart cleanly, but I promise you, we will get it apart. Oh, broke some more of the black casing. I'm pulling on the wires now. I'm going to have to take off the wires. Okay, so that's the shroud. And in case you're wondering why I'm wasting this, it doesn't really matter because this thing is useless anyways. Off balance, it doesn't work. It vibrates like crazy. Come on out. Just trying to lever this whole thing apart. Maybe I can break more of the plastic around it. This is really cheap plastic. I think this is what AVE would call, you know, used sewer pipe, if anything. There we go. There we go. That one went flying across the room. Now that kind of ruins my position here because I want to pull this the rotor off. And even this PCB, the circuit board supporting this brushless motor, oh my god, I am just ruining it. Well, we can try snipping a little bit more. It's gonna fly off and hit me in the eye. Thankfully I wear glasses because I'm old. Well, I mean, I don't wear glasses because I'm old, but old people definitely wear glasses. Oh no, I pulled one of the wires, one of the traces right off the board. Well, I mean, this thing is never going to live again, so there we go. How do I get this rotor off now? I feel like, yeah, I guess more snipping. Because I believe what happens is they put this on and then they heat stake the rotor on. Let's see if I can, well, the fan portion is no good, so let's chop that. There we go. The pivot still has grease, but I don't understand why this is always so stuck. Come on. Alright, so there we go. There is our little brushless motor. Let me give you a closer look at that. Here it is in the flesh, and this is the part where I might keep this in a functional state. I know, I just ripped it to shreds, but I mean, it's still functional. This is still a brushless motor. You just need to make a couple adjustments. I would love to find out how come this thing is always so stuck on. Like, I'm guessing the rotor is glued, so I might have to chomp away at it a little bit. But anyways, This here is the stator of the brushless motor. You know it's a stator because it stays stationary. So it doesn't turn. It's anchored back here into the black case. So this the whole fan surround thing that we broke, it's anchored into there. And then this here is the rotor. It rotates. Okay, so it'll go like this, and then the fan will be the fan hub will go onto here. So this, in essence, is the entire brushless motor, and underneath it is the entire drive circuitry, and we're going to get there in a moment. So, yeah, this is the rotor, and this actually secures the rotor in place. So, what are we looking at? Well, we're looking at 4 electromagnets, and very likely that these 2 electromagnets and these 2 share the same polarity. And then in here, this is a magnetic ring. Not sure if it'll come out of the metal portion. Nope, doesn't look like it. But I can guarantee you it's magnetic. See that? So on this there would be 4 poles, very likely. So I got 1 here. I can feel it. And then, oh, just jumped over, 1 here. And then just jumped over, 1 here. Just jumped over, 1 here. So by switching the polarities on these things, let's say that this side is north and this you can make it south. It'll pull the magnet until the south is directly opposed, and then you switch it to north, and then it'll push the north around, and then each 4 of these will do the same thing, each in their own turn. And what you see here, this is a I think it's called magnet steel. It's steel that is supposed to be really good at absorbing magnetic energy, which is what it's doing. So that coil is generating the electromagnet, and then this steel is strengthening it, focusing it, and directing it. And the reason why it's laminations, you see the layers of metal instead of one solid chunk, is to lower the amount of current that is circulating in there with the changing of magnetic fields. They're called eddy currents. So pretty simple, but the only thing that I'm looking at now is that the drive circuitry, which was supposed to be, in here, looks like it's inside the central pillar. You see how the central hub here is kind of thick? There's some grease there because this turns, but the center thing is kind of thick. I'm guessing the drive circuitry is in there because there is no drive circuitry. There's only one chip here, and that's a 211F on the bottom, 1922S. I believe that's a Hall sensor. I don't think... Yeah, it's connected to this. It's connected to the S, which is the sensor. See that? S. And then it goes over to here. That's where the chip is. I think this is also driving. Let's see. You know what? This is the driving chip. The positive goes through one of the legs of this winding. This winding goes across to... Looks like all the windings are wound together. So the positive goes through this one. And the negative... I don't know if I'm in shot here. So the positive comes in this way, goes through this leg, which we see there's wires attached to it. Don't know if you can tell right there. Okay, that's positive, and that's where it ends. And then the negative, which is here, comes through this chip here. This is the other end of a winding. It goes to the chip, and there's the other end of that winding, which goes to the chip. So it's actually 3 phases. Yeah, Because look, this one goes down, this one goes down, this one goes down, this one does not. So it looks like it has 3 phases, but they're in 4 quadrants. Super interesting. And also we can see that this one, N, is not connected to anything. This is a single-sided board. So there is no tachometer or a PWM accepting signal. There's just this 4-pin chip that must be driving the whole damn thing. That's so cool. Now there's no way I'm going to get this working again because, I don't know if you can see, but there's no way to keep this rotor centered because of the magnetic attraction. But this does mean that I can probably 3D print something at some point and get this thing working again, which will be really cool. But yeah, let me know in the comments below if you want me to try to get this thing going again. I might have to cut this this plastic off the central post here, but it might be doable. Let's see. Whoa. Does that look glued? Don't know, but it's off now. Oh, it looks like it was heat staked in there. This doesn't come out. So yeah, I can probably glue it, or I can just press my part on. Interesting. Well, if you want me to tackle that, let me know. I'm not sure what I'm going to do. Maybe I'm going to make another fan. I really don't know. I'm just going to use this for my base and glue that onto a base, and then press something in here. Like, probably going to put this into a 3D printed part and then press the whole thing onto this post. So yeah, this is the insides and probably the only part I'm salvaging from a cheap CPU cooler. Thanks for watching.